Okay, let's look at the section 9.4. This section talks about the function and cardinality, and the second topic is bijective functions. Right? So let's look at the relationship between functions and the cardinality. Right? Let's say you have two sets A and B. These are finite sets. Right? And there's a function, say from A to B. Right? Let's say if say function is 1 to 1, then the cardinality of B has to be at least as big as the cardinality of A, right? Why is that? All right, so let's look at an example where you have cardinality of B is smaller than cardinality of A. So I'm going to just to put the 3 elements in A and maybe a couple elements in B, right? Can we make a function so that it is 1 to 1? All right, so let's say 1 is mapped to A, right? Since it's 1 to 1, 2 cannot be mapped to A, so 2 has to be mapped to B, right? Since it's 1 to 1, 3 cannot be mapped to A, 3 cannot be mapped to B, but there's nothing else. So you can see that we cannot make a function. So that's why the cardinality of B must be at least as big as the cardinality of A. All right? If there's a function that is onto from A to B, then we know that the cardinality of A has to be at least as big as the cardinality of B, right? Why is that? All right, so let's look at an example where B has a larger cardinality. Say A has 1 and 2, and B could have maybe 3 elements, A, B, C, right? So let's try to make a function that is onto, right? So 1 is mapped to A and a 2 is mapped to B, but we cannot put any additional mapping because we already have 1 and 2 and nothing else. So you can see that we cannot cover C. All right, so therefore we have to make sure that the cardinality of A is at least as big as cardinality of B. All right, and the next topic, bijective function. Right, bijective is a fancy word for both injective and surjective at the same time. So it's 1 to 1, 1 to 1, and also on to. All right, so here's an example. Let's say you have a function from all real numbers except for 2 to all real numbers except for 3, right? Which is defined by 3x over x minus 2. All right, let's show that this function is 1 to 1. All right, so let's start with f of a1 is equal to f of a2, right? Which means that f of a1 is 3a1 over a1 minus 2, right? F of a2 is 3a2 over a2 minus 2, right? Then cross multiply, you're going to get, right, 3a1 times a2, so 3a1 a2, right? So I'm just multiplying these guys, and 3a1 and the negative 2, so it's going to be negative 6a1, right? Right, then you have 3a2 times a1, so it's a 3a2 a1 minus 6a2, right? Let's simplify. 3a1 a2 and a 3a2 a1, they're the same, so we can cancel those, right? And also you can divide both sides through by negative 6 to conclude that, so negative 6 cancel well, a1 is equal to A2, right? So this shows that F is definitely 1 to 1. All right. Let's show that F is also onto. Right. To show that this is onto, I'm doing a little bit of scratch work. Here is our my scratch work. Scratch work. Right. So we want to find some A such that this is equal to B. Right. So we know that F of A would be 3A over A minus 2, which is equal to B. Right? Let's try to solve for A. So multiply both sides by A minus 2 to get the 3A is equal to BA minus 2B. Right? Then I'm gonna subtract the 3A and also add 2B. So that means that I'm gonna put this guy on this side and I'm gonna put this guy on the other side. So you're gonna get a positive 2B is equal to BA minus 3A. So B minus 3A. Right? So then we can just divide through by quantity B minus 3. That way we can get A is equal to 2B over B minus 3. Right? So this is the A we want. Right? So here. So we're going to pick choose any element B, which is in the codomain. So this is going to be all real numbers except for 3. Right? We choose that. Then we know that there exists A, which is going to be 2B over B minus 3. Right? Now we know that the reason why 3 is eliminated, because if B is 3, then this expression is undefined because the denominator is 0. Right? And also this guy is never equals to 2. So we know that this guy is always a real number except for 2. Right? Such that, all right, let's look at f of a. Right? F of a, so this magic a will probably give you exactly b. So 2b over b minus 3. Right? So let's plug it into the function. So it's a 3 times x is 2b over b minus 3 all over x is 2b over b minus 3 minus 2. Right? To simplify this expression, I'm going to multiply top and bottom by b minus 3. So I'm going to multiply top by b minus 3 and a b minus 3. Right? That way we will get, so I'm going to do it here. Right? So b minus 3 and b minus 3 cancel out. So you're going to get 6b on top. Right? Then you have b minus 3 cancel with this guy. So you're going to get the 2b. Right? Then negative 2 times b minus 3 would be negative times b is negative 2b. Negative 2 times negative 3 is positive 6. Right? So you can see that you can cancel those. Right? And the 6 and the 6 canceled, and which will give you exactly equal to b. Right? So we found the a such that the f of a is exactly equal to b. Right? So therefore, this function f is also onto. All right, that's it. I hope that this was clear.